So guys, I'm part of Juniper Networks through the Contrail acquisition. And before Contrail, I used to run. Let me go back to my background, then you can appreciate where I'm coming from. I come from a concrete operator world. This is my first experience in the equipment vendor world, and so we'll see how it works. So this is my background. From 2005 to 2012, I was leading the network architecture team for Microsoft Online Services. So I built the Windows Azure network infrastructure, Microsoft Linux infrastructure, Office 365 infrastructure, Hotmail infrastructure. The network infrastructure was, what is that?
Show you.
Oops.
Might want to plug that in.
Is it all right? Okay, I'm going to look at that guy over there to see if he is sitting out here.
Oh, I can plug this.
So, oh yeah, I think that must be happening. And so I came into the whole cloud services, data center services in 2005. But before that, I was in unit. I used to run the core backbone engineering team for AS701, 702, 703, as well as 14551, which is the South American AS.
Was the network team responsible for certificate management on Persia?
So that unfortunately happened after I left. So these are the new guys that are running it. So
Sorry.
that's all right. That's all right. So before 1999, I worked for BSNL. I built the first backbone in India from 1994 onward, and then I joined Advanced Network Services, and I left Advanced. Actually, VNS got acquired by UNET in 1999. That's how I became part of UNET. So let me go to the presentation layout, because I think it's important to understand how I'm going to take this presentation so that you guys can ask me question when appropriate. So I do want to talk about the problem space, because if you don't understand the problem space, there is no point in talking about what solution can do. Like, what could happen is irrelevant. What should happen is the one that we should talk about. And then I'm going to talk about the solution to this problem space, what kind of technology applicability that has. So basically the use cases that the solution can really help with. The next one is the Contrail technology overview, and that's where I'm going to spend most of the time, 25 minutes. And then I have a screencast demo, and I did make it a screencast demo because I didn't want to spend too much time just to fiddle around with the screens, at least for this one. But I can do a demo with anybody interested going forward. And then we can do additional whiteboarding going forward, and the Q&A has 15 minutes left at the end of it. So let's talk about the problem space. So we all know that the application itself is evolving. So if you look at the left-hand side of the screen, this is how the typical enterprise application used to look like. This is what a typical enterprise IT data center looks like. And when I actually joined Microsoft in 2005, this is how it used to look like also. So you have this, basically the WAN, the routers where you have the VLAN, ACLs. Then you have VLAN, you can optionally have the firewalls and the IPS if the property has PCIe and all those crap. And then you have the load balancer with the VLANs and then the physical servers, right? So every time my data center director, I remember the guy, pretty nice gentleman, he used to come to me and say that, hey, Parantap, I have this particular property, which we used to call them property, who is sitting in a VLAN, and he is in a VLAN in a part of the colo in the data center which is completely full. And he doesn't want to buy another pair of load balancer, and I have to put his new rack in another corner of the data center, and can you connect this VLAN together? I said, hell no, because what happens when you do that, your whole infrastructure goes to dump. And your whole infrastructure basically of the spanning tree, I said that for deployment efficiency, I'm not going to sacrifice the operability of the network. So that's how it all came together so far. So if you look at the standard large-scale enterprise infrastructure, you have colos and you have spanning tree and you have a small triangle of switches there, and you never deviate from it. Basically, people who deviate from that, they are basically done, because it's going to come back. Karma is going to come back pretty much. So what happens is, and what was happening was this standalone application. Let me go to hit the click. So this is the journey that was happening. The standalone application were evolving into an evolving application which works on a resource pool. Nobody cares about how you had the load balancer connected here, because if you have a static load balancer there, you are going to either run out of the capacity, or they are going to be so less full, it's going to be a huge amount of resource which is blocked and locked and nobody uses it. So, and people knew that they have to get away from that paradigm. So what happened was now you have this new paradigm, which a lot of like Bing classically has been working in this new paradigm for last several years. So where you have compute pool, you have storage pool, you have load balancer services pool, you have firewall services pool, and somehow this has to be tied together in a pretty intelligent way so that you can give this whole segmentation of VLAN, and then the application themselves should be able to scale out and scale down on an as needed basis. The Google guys were solving the same problem in Silicon Valley, and we are up in Redmond trying to solve the same problem, but this problem was pretty much the same. And the idea was, if you have this application running in a particular enterprise data center, and you have to use resource which is sitting in the external cloud, which is in Amazon Web Services or in Google's GCE, how do you do it, right? So there has to be those mechanisms, because the pool of resources is global. The storage pool is there. There is no point in building your own silos and not use it or keep it aside. Like those strategies are going to fall off like karma. Now, so I'm going to get into a set of marketing slides, so pardon me for that. I know you guys are pretty technical. So, but let me go through it, and then I'm going to jump into the technology overview part, okay? So what happens is you do need, so the rings that we showed, the dotted line ring that you showed, that has to come in. There is no question. It has to come in. It has to come in a way which is scalable, right? And which is scalable and which scales like the internet. Now, so you need an open, scalable, flexible infrastructure software solution which can pool the resources efficiently and automate new services and then build on existing network capacity. You don't want to throw away the data centers that you have built, because the next data center, the greenfield data center, is going to come in July. And if all your technology is waiting for July and you have 20 plus data centers doing nothing, that's a bad story, right? And you have to use your existing network capacity, and basically you have to orchestrate all these things seamlessly and securely to leverage all resource pool available everywhere. So that's the problem space, right? Now, once you get a solution to that problem space, it is applicable in all the major domains that you have there. And that's the truth, because what happens is you are giving this capability where you can pull in any service pool or any resource pool on an as needed basis and connect it to an application. And this capability is extremely important, right? So when this Contrail guys approached us, I said, hey, you are solving the right problem, so why don't I join you? So what happened here was the use cases, the 3 use cases that come in are use case number 1, which is data center virtualization. So this is the data center that you see today in the enterprise, where you have the switches and these triangles and whatever going on, and you have these VLANs, which is meant for HR or marketing or resources. But going forward, you build this clause-based architecture in the data center, because, and we actually went through this journey, because building this tree-like stuff is meant for death, basically. Because what happens, these VMs keep on migrating around. Where are you going to put the bandwidth? If the bandwidth is not uniform, you are locking a VM, or you're locking a function, or you're locking an application at a particular part of the data center. So that's where the whole clause-based thing came in. And in Microsoft, we put together a clause using pure BGP, and you had BGP to the top of rack. I didn't believe even in OSPF and stuff, to be honest. Because the thing is, if you really want to run a good infrastructure, you should actually invest in a protocol that is well-made, well-developed, all vendors support it, and you have to have an entrance barrier that is low. So you don't want to complicate your protocol stack. So you basically have BGP down to the top of rack. I envied the Google guys. They kind of did their own stuff in their class. I didn't have that particular leverage there, but this is one of the use cases. Now the next thing is, and this is something which really attracted me about the Contrail solution. So what they're trying to do was, you have the virtual network sitting in the managed private cloud or the service provider infrastructure as a service cloud, or VPC or something. And then you have this legacy data center network, which is a VLAN, and a legacy branch office, which is another VLAN sitting somewhere in the regular branch offices. And now it's not about technology. It's basically what do you want to do, and how can you have technology do that for you, right? So if you have an application sitting here, which is written in a VLAN, and you want to access the storage resource out there or a compute resource out there, how can you do the access in a way where it is a single virtual network which ties it together in a segmented way, right? So that was a problem space. So what I found here was, basically the L3 VPN technology, which is proven, and we had PIP and in our old UNet MCI days, and those things, you have to tie in that L3 VPN with the virtual network in a seamless way, because it is there already. 10,000, 20,000 of them are already deployed, and you have virtual networks spawning up in each data center or in an enterprise. You have a question? What's that? Okay. Perfect. So let me not spend too much time. I had just only 8 minutes for this one. And you get it most probably. So and this one is coming up more and more with the telco people, because what they want to do pretty much is the problem space is kind of same, right? Oh, the frog. Okay, perfect. So the problem space is pretty much the same. What the telco guys want to do is they have all this business edge, broadband edge, and mobile edge. And I was solving this problem in UNet because the edge engineering manager was my peer. And what they want to do is they want to add services to this last mile. And what we were doing at that time was basically we had an arbor sitting somewhere using MPLS. We are bringing the DDoS mitigation traffic to the arbor, scrubbing it, and sending it back there. But when you buy an appliance, an arbor or something, you are locking all your resources, and you are basically locked till you amortize the whole cost out of it for 3 years, and you're done, right? So what these guys are trying to do.
Hallelujah.
What's that?
Brother.
You got it, right? Perfect. So what happens is, and I think the telco guys are also getting the hang of it. So you need to have all the services based on x86. And x86, it could be sitting anywhere, right? And then you can flush those x86 and put more of them doing arbor DDoS or arbor type of DDoS, or more of them for IPS, more of them for firewall, do whatever with them. But depending on your need, you kind of spawn them up. And once you spawn them up, then basically you have to connect those services back to this edge. And that's the problem. And I think it kind of comes under the same solution space, and that's the third use case here. So now, this is a bridging slide. So just to get into the Contrail side of how the Contrail technology works. So you have this physical network. Now the virtual network overlay is built. Now on the top of it, how do you actually, what is the control plane for this virtual overlay network? And is the control plane resilient? Does it need a 5.9 infrastructure? Do you have to keep all those boxes in the MDF of your data center, which is 5.9 available, in order for the services to be 5.9 available? And those are going to all come up in the control plane discussion. And then you'll see that the control plane is really distributed. You can run it in any server anywhere in the data center, and they kind of sync up with each other. And then on the top of it, how do you create these VNs? And how do you get analytics out of it? So you have the OpenStack, Cloud Stack, and you can have a REST API to connect with this control plane and the management plane. So I think I'm 12 minutes into it, so I'm doing pretty well. So this is the first view of the technology itself, right? So what happens here is, I think there are a few key points, and these are all, it's kind of hidden here, but let me go over it one by one because it's all important. What happens is, the technology, you have a virtualized server here, you have a virtualized server here, a VM sitting here. Both of them could be part of the same VM. You can have a bare metal server. A lot of them, believe me, are just bare metal, right? And you can connect them to the same VM. Now this IP fabric underlay network, it's extremely important because this one doesn't need MPLS or anything. It just needs a IP fabric. And as I said, like you had a clause where you have BGP running to the top of rack because you can do it. It's not a, it's almost a commodity protocol implementation. And then basically this is the network which is inside the data center. It can go beyond the data center. It can go between data center. Who cares? IP is so ubiquitous. You can basically have IP everywhere. But the complexity of having that VLAN-based segmentation and creating that segmentation in the network gets sucked into the server itself. And you make x86 do the work for you, right? And because it's kind of lot more malleable. So if you go up to this one, the Contrail SDN system, so you have the control plane which talks BGP. And it talks BGP is the P router of the L3 VPN, and it just talks BGP with everyone. But when the control system talks with the virtualized server here, that is the XMPP channel, which is also a standard protocol, but it is XMPP. You don't want to have 10,000 servers with 10,000 TCP sessions permitting on the same controller. It has to be basically scaled out in a way which is sustainable. And using XMPP, you can actually exchange a lot more kinds of messages and stuff. Go ahead.
So for NFV
Yep.
type applications that don't reside in a hypervisor necessarily, or
Right.
reside in a hypervisor that isn't going to support the agent or whatever. What's outside of that? How are you going to integrate that into classification?
So the solution works on bare metal servers. It doesn't need hypervisor. You can actually put the vRouter in the kernel as a kernel loadable module, and you can have a vAgent. It works completely with a bare metal server.
Can the vRouter functionality be offboarded?
I'll come to that.
Okay.
I'll
great.
come to that. I knew that you guys would be interested in it, and I'm definitely going to come to that. So think about the different components. So you have XMPP here. You have REST API communication with the SDN control system, and I have a slide on how does the SDN control system look inside. So I do have that. So do ask me a question at that time. So this is how a control system node looks inside, and I have a exact compute node view right after this, right? So I think this has a lot of nuances which are hidden inside it. Because let me go over my data center background, and then it's going to come out. So think of this control node, which are talking BGP. These are basically running on regular server, bare metal server or VM, doesn't matter. These are running on regular server, and these are all active. So it's not that you have a primary backup and you have all this mumbo jumbo to sync up everything. So if you have it all, because this is how the internet is built, it's all BGP, right? And now what happens is, this whole SDN system has to be 5.9 or 6.9 available. You cannot afford to lose the system, right? But this control node itself might be sitting on a rack in the data center, which has a single power feed, which has 999 availability. So the idea is, how can you build a 5.9 available system using 3.9 available components? That's the basic problem it is trying to solve, right? So you don't have to put all this thing in the MDF of the data center, which is almost double the cost to build each megawatt inside the MDF is almost double the cost than the regular colo megawatts. And you can basically put this node anywhere in the server, and this guy, it's just turning on a command. You have the build, you just say that configure this as a configuration node or a config node, and it comes up as a control node. And these things all sync up with each other, and the compute node kind of knows what are the control node, and it starts working, right? So this whole system is built for a 5.9 kind of availability. And if you look at, I think this thing are getting a little more vague here. So here, the communication between the XMPP, between the compute node and the control node is XMPP. And the communication, so this control node can actually configure and manage any service node, that is a SRX or whoever firewall load balancer it is. Or it can actually configure the gateway nodes that are the MX, and that's where the Puppet kind of stuff comes in, which Jeremy covered, right? So this whole thing can come together, right? You don't have to jump from console to orchestrate a service. You have to have a story where everything comes together. Otherwise, somebody else would have a story, right? So coming back to your question. So this is how a compute node looks. And I come from a pure layer 3 background, and so it elated me when I saw this particular look, because you have the vRouter forwarding plane, which has basically the VRF, which are belonging to each VN has a VRF pretty much, and you have the virtual machine, the forwarding plane. This is the vRouter component which stays within the kernel, and it's a kernel loadable module. And then if you have the Intel DPDK kind of support, you can even run it in user space. But then the vRouter agent, it runs in the user space. So this guy basically learns all the information from everywhere, and it actually puts it in the VRF RIP, right? And then this guy connect to this RIP, and what comes out is pure IP. The GRD part is very, very important. It's pure IP that comes out, because that's how the data centers of today's world run, and that's how they work.
So it's a tunnel fabric.
What's that?
You're building a tunnel fabric again. So the
It's a
data
tunnel.
center core becomes a tunnel fabric.
You're absolutely right.
So the vRouter forwarding plane,
Yep.
you're suggesting, you're drawing parallels to a VRF in an MPLS router instance, right?
You're
So
right.
what is it actually? Is it OVS or is it?
It's our own vRouter. It's not OVS. It's an OVS equivalent.
It's actually an L3VPN router.
Okay, right.
It is an L3VPN router. It implements the exact same functionality you find on
It's a
physical.
software agent.
It just
Yep.
happens to be implemented in software, but
That's fine. I've got
It
no problem with
does
software. I'm
OVS.
just trying to understand whether it's OVS,
and
which
it
is what most other-
interoperates with an off-the-shelf L3VPN box.
Right. So you're using XMPP to configure a vRouter, which is your own agent in the edge node,
Yep.
right?
Yep.
Which is a messaging protocol, which is fine because you're just exchanging configuration data.
Correct.
then your tunnels come out of the edge, and then we use a tunnel fabric.
Right, and the good thing is this tunnel can terminate on any router that supports MPLS over GRE. It could be AMX, it could be ASR9K. Any router that supports that standard should be able to decap it and send it out, right?
The disadvantage with GRE is load balancing, ECMP load balancing.
You can always make it encap it in a UDP and throw in some ports to do the variants, and like the whole clause works on
Well, you can do that.
IP hashing,
but
right?
do you do that, right?
So it's basically, we have it in our engineering plan, we'll put it,
Yeah.
because we are taking it in phases, right? Once it shows up as a problem, we'll just put it. It's not a big deal.
Right. So you're saying VXLAN if you want that.
Yeah,
Because
you can do
VXLAN's got
VXLAN.
ECMP capacity for the tunnel fabric to load balance
Correct,
over
correct,
ECMP
correct.
paths.
Correct.
But there's also an advantage in using MPLS over GRE because you can tunnel it from an edge to an edge. So you can terminate GRE tunnels in a hardware
Right.
and a WAN edge, like on a PE or a CE router or something like
Exactly. And as you saw, I think de-encapping the VXLAN in a hardware is going to come up. I think that's going to be also ubiquitous because you saw the Juniper roadmap where de-encapping is coming up, right?
that. Yeah.
The
that's right.
VXLAN.
No,
It's not a big deal,
yeah,
right?
yeah.
It's not a
The
big
idea of decapping GRE
Right.
is not popular
Right.
because
So
of the load balancing problem, right?
yeah, you're right. You're absolutely right. And I go back to my Microsoft days. We were actually changing the source IP of the encap to introduce the IP variants.
Yeah. So
Because we
like the
didn't have any
yeah.
standardized real estate on the IP packet using which you can actually flow the
That's a bit
IP.
excessive because even then you wouldn't be guaranteed of having
Oh, it has other problems.
stochastic yeah. You need to have enough entropy to be able to make it work,
Yeah.
and the stochastic nature of GRE that breaks.
You're absolutely, your point on.
So where does layer 4 policy get applied?
What's that?
Layer 4 policy.
So the layer 4 policy, what happens here is, so you mean the ACL kind of stuff, right? Are you talking about the ACL, the stateful ACL, stateless kind of ACL, like ACLs? So,
We've heard of them once or twice.
huh?
We've heard of them once or twice.
Right. So in this particular model, I wasn't aware, like if you were talking about a load balancer with I rules and all
Oh,
those
yeah,
things,
just
right? Not L4 to L7,
simple
just pure
self-provisioning
ACL.
security
So what
policy.
happens is we kind of push through the centralized orchestration. We say that from this VN to this virtual network, only allow port 80 and port blah blah blah, and then the system actually distributes it back to all the VN that has this. And when a packet comes in, it actually talks to the vRouter agent through a slow path saying that, hey, am I allowed to carry it? If you are allowed to carry it, you put a flow table and boom,
Okay.
everything rest goes.
So it's flow-based forwarding.
Yep,
so that-
it's
okay.
flow-based
Just
forwarding.
one more question.
Yeah.
You're talking about tunnels coming out of the V routers. Are you full meshing? So if I was in a data center, can I full mesh and route locally at the edge?
So the thing is, it's on demand. It's on demand tunnel. You don't have to. It's not interface tunnel 01.
Yeah,
and
no,
you
I
have,
understand,
right,
yeah.
right.
That's
Yeah.
what I'm drilling into is how's your architecture put together.
So this is how it works basically.
Yeah.
So you have a packet coming from the guest OS. The guest OS thinks that it is connected to a virtual network. Think of it as a subnet, a /24 or something. Either it has to go to the default if it
Yeah.
doesn't belong to him, or it goes to some other boxes in the same subnet. Now it sends an ARP. The vRouter actually intercepts the ARP saying that, hey, okay, fine, you want to go there. It actually sends back a VRRP MAC address. The guest OS doesn't know even what is going on, right? Now, he sends a packet with a VRRP MAC address, but the vRouter in the meantime has found out, hey, this is where he wants to go, blah, blah, blah. And then he kind of ignores the MAC address and he encapsulates it into the, right now the implementation is you have an MPLS tag, you have a GRE header, and you know which GRE endpoint it has to go to because that whole information got already pre-populated in that one. And then it sends there, the guy gets the packet, it takes out the GRE part, it sees the MPLS tag, it says, that, oh, you are meant for this vRouter, and it kind of sends it back up to the VM. It's as simple as that. Okay. Great.
Sorry, I just wanted to highlight for the previous gentleman that one of the main differences between this system and other competing approaches is that when traffic flows between VLANs,
Yeah.
there's no intermediate point. It's end-to-end forwarded from the ingress hypervisor to the egress hypervisor.
Yeah.
And so
you forward it into the right tunnel.
ACLs are applied both at ingress and egress without having to go to sort of a virtual, Linux router in between.
Yeah, you don't need to route them because they're rooted
So
at the edge.
that's the main difference.
Yeah. Sorry, I missed that
Yeah,
part.
you don't
Sorry
need to
about
you don't need to route them on a tree. You don't have to go and find the router in the core and bounce them back down. Once they come out of the edge, they're already tunneled to where they need to be. Tunnel fabric.
And as you are aware, most traffic in a web app actually crosses process tiers rather
Yeah.
than staying within
Yeah.
the same.
Right.
Yes.
So layer,
Thanks.
layer 2 MAC address tables are being stored in the edge V router also, right?
So yeah, that's the plan. So we are going to support
Flooding.
EVPN,
Okay.
EVPN going forward. It's going to be standard EVPN. And what you see here is also ITF standard. So that's the end system, VPN end system, which Pedro is the author of. It has been accepted in the work group. And it's all standard based. It's not no proprietary mumbo jumbo going on here. So this one actually talks about how do you connect. So I was talking about seamlessly connecting the virtual network with the L3 VPN, and this one actually talks exactly about that. And I thought that it would be a good idea to put a slide on. So you have this VNS system, and it's a standard P router, and then you have the P router of the regular MPLS VPN that is out there. Now, this P router and the control node, it actually talks pure BGP. There is no, you don't have to support anything else on this P router, right? And this one, to the P router, uses the standard encaps that we talked about. From here to here, the other P router, you can use option B, MPLS, like you can even not use option A and have VLAN stack, which is not scalable, of course. And then from this P gateway, right now you can get into the public network because that guy does hardware de-encapsulation of all the packets, so you have the full line rate of the P gateway. Now, anything else I would like to talk about here? Of course, here we see that say that the NMS is using netconf, is programming this. You can use Puppet and stuff, and then you can have this control node program them directly. Depends on the who owns this part, right? If that is pip, you're not going to use.
If you're
any of
communicating
those.
between the orchestrator, if you're communicating the control plane over BGP using
Right.
IPBGP,
Yeah.
I'm a little concerned about the bandwidth there. Do the routers have the capacity to thump enough control traffic along that control
Oh
plane?
yeah. So those things I'm not worried about it at all. Because what happens is if you have control node, think of it as 12 control node, right?
Yeah.
This is going to be just 12 TCP sessions. Like even back in UNET when you used to do the benchmarking on these routers, like all edge gateways, like I'm talking about 2003, right? They used to support 150, at least 150 UBGP session, and towards IBGP, it's a single group.
Yeah.
You don't even have to create different group. It's a single update which gets created, boom, goes out. The scaling, not a problem.
Okay, so I'm more concerned that BGP sits in the control plane, but
Right.
it sits on the supervisor or wherever it is, and there's usually a CPU in there that's worth about 50 cents, and there's no memory, right?
Yeah.
Even in an internet switch, there's not that much. Internet class MS960s, not a whole lot of memory in those, right? Are we able to thump? What do we need? 50 megabits per second of BGP interconnect to hook these
So
controllers
see the
together?
BGP itself, the throughput of BGP, it's a TCP session, right?
Yes.
Where if you look at the BGP benchmarking mechanism that typically the telcos do, what you have is you have the internet table, 400K,
Yeah.
then a TCP session opens up. How long does it take for the BGP to convert? So you have all this table and whoop, it goes through
Yeah.
a single TCP session, and it depends on how much you want to actually pass through. That's where the convergence come in. Now the actual,
To give you some numbers, on your 10-year-old router, if it's sitting on internet, it's listening to about 100 updates per second just as internet background noise. Updates per minute, sorry.
Yeah.
Around 100 per minute.
right.
On a system like this, you're probably going to have 10 updates a day because that's when your VMs move.
Yeah.
The scale that we're seeing on enterprise L3 VPN is an order of magnitude higher
Yeah.
that you're going to see on any data center. So, based on a 10-year-old CPU, mobile CPU,
Right.
the number of updates is insignificant compared to what you're going to see in a data center.
Please do.
I mean,
Hell
This
of
is fun.
dubious, but let's move on.
But,
Yeah.
but I can actually, if you look at the telco way of benchmarking BGP performance on a router or anything, those are standard mechanisms that people use. But given the scale this one is going to use, I wasn't concerned when I looked at the solution, to be honest.
Right, okay.
But so let me go to this one. This is pretty important because this comes in the service chaining, the NFV question you had. And so how do you really do service chaining? I think people have been trying to do service chaining for some time. I know other vendors have tried to do it. But the fact here is this one comes fundamentally to the resource pooling problem that I actually coded in the first slide. Because it is fundamental. So if you have, so my answer to the data center director was, hey, get another VLAN in the other part of the data center, buy another pair of load balancer, and turn on the service there, right? And then the guys who are happy were the guys who are selling the load balancer. I refused to take any gift but the fact is, they basically were happy because you had to buy so many load balancers in order to support a lack of functionality that comes from using old, archaic L2 protocols, weak control planes, right? And that was getting manifested by getting more revenue for the load balancing vendor. So that is what was happening. And this load balancer pair was getting locked in a VLAN. They were getting used like 2% of its capacity sometimes, and sometimes it was 100%, and then you have to buy another bigger load balancer because it's a scale-up model. And so now what happens is you have to pull those resources and you have to put it in the inline with a particular service that is getting orchestrated, right? And that's where the service chaining comes in. So the way it works is pretty simple, and people who are familiar with the L3BP and the VNS type, they might even find it out through the picture directly. So you have this routing and tenant routing instance here and a tenant routing instance here, and you basically have to make the traffic go through a couple of more service endpoints, a load balancer and a firewall, for example. So what happens is this guy actually announces the prefix to an intermediate one who receives the next hop, announces it to another intermediate one who receives the next hop, and it sends it to here. So for this guy, it seems that if you want to send traffic to this tenant, actually send it to him. And then if he has to send traffic to him, he actually sends it to this guy, right? And how do you orchestrate the actual routing information in each of these components? And that comes into the centralized Contrail SDN system. So you put in the right places and just make the thing, and it could be a 7 tuple even. It doesn't need to be honest, a 5 tuple kind of a thing, or even 2 tuple.
Yeah.
You?
No, I was just going, yeah.
Yeah, got it.
I
Yep.
got it, yeah.
So I am into 31 minutes. I'm doing pretty fast. So I'll spend some moment on the demo itself. I think this is the last slide on the technology. I can do some whiteboarding if you guys want to do it, and then I can go. I think I'm ahead by 5 minutes almost.
So you said you could do this on bare metal. So
Right.
that would imply you're not using a hypervisor switch, or you're not replacing the hypervisor. You're actually providing an agent that replaces
Correct.
a NIC or something in the operating system.
Correct.
We're
That's
replacing the Linux bridge kernel module. So you can create as many tap interfaces as you.
Well, you're shipping a kernel module that can be inserted or can be loaded.
We're shipping a kernel module that can be loaded and has the same interfaces as the Linux bridge kernel.
And VMware doing something
Not
like
at the
that?
moment.
Not at the moment.
Not for the.
We'll figure it out.
Not for our.
I know why you're chuckling, but
Some things are out of your control.
right. But we'll figure it out.
There are
We'll
things
figure
out
it
of our
out.
control.
I think VMware might be working on something similar, but not the same.
They're all working on something similar, right? They're all pretty much like this.
Right.
They're all different, but they're all.
Like Dan has similar, or Dan Winland has similar roles
Right.
in the
I
team.
think the fact is the problem space is there. Everybody sees the problem space, and human mind kind of converges into few ways of solving it, and that's it. Everybody going that way.
Yeah, no, but I mean, I think that there's value in providing a consistent. I mean, obviously, you're missing a gap in the enterprise space,
Right.
but in the service provider space, having a consistent view whether you're bare metal and running at the Linux networking stack, or whether you're running inside of a hypervisor,
Right.
it solves problems.
Also,
Yeah,
this is it's a product targeted at service provider cloud plays.
Yeah, absolutely.
Well, no, but even in the enterprise, I think the design principle of a standard-based interoperable that could be bare metal or could be across hypervisor.
Yeah, that becomes
that's
the.
not a service provider enterprise.
Yeah, but let's be real here. If it doesn't work with VMware, you're not in the enterprise. Let's be real. I
That's
mean, come on.
not necessarily true.
Yeah, I think.
We'll see.
There's-
These are big
There's
companies.
virtualization.
Talk to you next year about your shipped licenses for VMware infrastructure if your plugin isn't working. It's not going to happen.
See, the thing is, yeah, there are some short-term challenges and stuff. We will figure those out, but as long as you are in the right railway path of solving the right problem, I think eventually things will.
I think this is actually rather elegant, and I like the fact that you can have a consistent network topology, whether you're Linux bare metal or you're providing a hypervisor.
Right.
The reality is that you have another software vendor that's probably not so incented to interoperate right now.
Yes.
In the enterprise, it's not out of your control, right?
Yeah, agree. So let me go to the demo part, and so the fact is And the reason I had it as a screencast demo because I really wanted to spend more time in the architecture. And this one was supposed to be a plugin for 8 minutes. All this complexity kind of gets hidden under a UI, and it's like Kiriti says, you have this whole car that is working with a humongous amount of complexity in each part of the engine and the axles and the gears. But overall, you have to hide them, right? And so let me see. So what this talks about is you have a front end and a back end network, virtual networks. It's all getting instantiated inside VMs. And what it actually, let me pause it for a second. Hold on. So what it tries to do is you create the virtual network, you define the policies between the virtual network, the question the gentleman had, and it gets actually distributed to all the VMs that are participating in that virtual network. Then you have, you create a VM instance, you allocate a floating point IP, which is not a floating point IP, a floating IP, which kind of draws the traffic into those VM, and then you ensure the web application is accessible via web. So that's the demo is. We actually went in late last night, and we added 2 more parts. One is we wanted to show the analytics part. So all this inter-VN traffic that is going in. So can you see the traffic volume going up and down? And then we went in and added a PCAP capture. And you can directly capture all this traffic based on a filter, whatever you choose to put on the VN, and send it to a packet capture, and you can display the packet capture. Because you have access to x86 now with this agent, and you go from there. So I'll try to actually talk about it when it shows. So it's an OpenStack based system. So you guys are all familiar with this UI. You go in, create 3 virtual networks, front end, back end, and oh, it takes its time. So you allocate the IP address. This is the VLAN subnet that you are putting for the VN. And this is the public network which is accessible from the public. So basically whatever you put in the public network, it gets announced and you can access. So now this is the policy definition, which says that what VNs can communicate with what other VN using what protocols. So a front end and a back end, you might allow only database protocols, blah, blah, blah. And you define the network. Apply the policy. So it's kind of boring, but you can see how it works.
As we're going through the boring parts, so you know you have both the integration with the OpenStack platforms as well as the integration with bare metal, but not controlled provision via OpenStack bare metal.
Right.
Now, so as you're controlling your security groups inside of here, is the plugins that you've written creating a like pulling all the available subnets and informations to add to those security groups? Or how's that working?
Right. So Pedro, you want to address that?
So, what was the question? Whether when defining the policy, if
Well, so you're doing your security group saying these subnet, these hosts can talk to these hosts, right?
So this is where the VMs get created. So we'll take it after
understand
this
this.
demo, and we'll answer that.
Oh yeah, I was just kind of
So let
curious.
me
So you talked about your plugin, your kernel loadable modules that you're putting on a non-OpenStack node, right? So you got a
Right.
service node out there somewhere
Right.
that's being consumed or communicated to by your instances, and you want to create a slice for a slice or security zone where they can communicate.
Right.
Are you pulling in these external resources that are not? 'Cause there's OpenStack bare metal where even though a physical instance can be treated as a virtual instance, but kind of these I don't know.
I know
you
the
got a
bare
firewall
metal
out
is
there.
not getting orchestrated through OpenStack. How do you basically pulling in that information and doing a centralized
Yeah, well,
orchestration?
the question
That's
was, are
it.
you linking the view of the physical non-OpenStack network with the OpenStack instances
See,
now?
the thing is, if you have the control node, and the control node just needs to know if you have the V router and the V agent running on the bare metal. So the control node needs to know that what is the physical IP of that guy, and what is the machine itself, what virtual IP it needs, right?
Yeah.
And then it basically has both the information. That is the main information that you need in the control node.
Yeah, I'm getting at that. I'm asking, are you populating those
So,
nodes in the
I
instances
think-
table, or?
Oh, okay.
So I think in the demos we typically do, very often what we show is an MX on an external network
Uh-huh.
that is defined, where the only thing that you need to do is define that network and a route target.
Okay.
And if we did that, and today we do that via an API call.
Mm-hmm.
We have a UI that Parantap is going to show later that will allow you to do that, but typically we do that through an API call. But if you define such a network, then it could show up in that menu.
It's defining your list there.
Right.
Okay.
So you can take a bunch of bare metal servers that you associate with a given network and make it interrupt directly in OpenStack.
Okay. Cool.
So now you are launching just VMs in those VMs, the virtual networks, and this is a standard OpenStack way of doing it. And now you associate that particular VM, which particular virtual network it gets connected to. So it's as if, think of it, it's all virtual. You had to have this physical boxes connecting to VLAN in one paradigm, and you had to spend 2 weeks to put together the VLAN, configure the switches, and all those things. And I was on the wrong end of that side at one time. But here it's all kind of virtual. So
you guys are supporting floating today and security policy self-provision.
Yep.
Great.
So now you have launching the VM in public network. So you basically get the VMs launched, and it's a Ubuntu image.
Things a bit more stored.
So now basically you have the instances ready and they have the application, and now you are basically going in through the public into the floating IP that got defined, and you are seeing this application running. So it's coming to the front end, going to the back end, the database is running in the back end, and you see it from there. It's basically just doing some operation in the application. Now this one goes into the web console, which is the monitoring and the analytics part. And here you log into the web console. That was Horizon UI. This is basically Contrail's web console. And you see the traffic volume, the back end versus front end. You can visually see what is going on in those traffic volume. And traffic between back end and the front end.
Okay, question.
Yep.
Since you integrated this OpenStack, do you expose any of these as WSGI elements so you can pull that up into the Horizon dashboard?
So what our strategy to put it up?
We expose both the APIs. So we convert between quantum APIs and our own APIs for the data model. The data we collect gets exposed in a centralized database, and we publish a schema for that. So
I mean, you guys got a nice little web graphs and stuff like
Right.
that. And I mean, APIs are great, and but it's also nice just to hack together a little WSGI element.
So it is
take that
an
feedback.
SQL queryable.
Okay.
It's a Cassandra interface that this particular web app is using.
Okay.
So the app doesn't really have the logic for data aggregation. The data is collected centrally, and you can do a query. So you yourself, if you want to do, even text-based.
If I wanted to build a car, I could do that too. I mean,
Well, I mean, I think to Colin's point, it is nice. I mean, one of the nice things about OpenStack dashboard is it's all right there. So if you're handing it out as a self-provision thing, so maybe thinking about even if it's a fork, I think.
I mean, you're going through a web interface. And
Right.
I know
It's just
WSGI is not the most elegant thing to code in, but to be able to aggregate, especially in the admin dashboards,
Right.
to be able to just pull something that's already generated, already developed.
Let's take that feedback.
I mean, it's just a thought.
No,
I don't
that's
know.
awesome. And
I'm
this
just
is
a
why
guy.
we are here,
No,
right?
but it's two
This is why we
different
are-
places that a customer's gonna have to go to self-provision. So
Right.
if you can collapse it into one.
Collapse
it's
it into a
always
one.
nice.
That's the overall goal anyway. I think that's the
Yeah.
The flip side here is that Contrail's not as far along. Right, so Contrail's not all that old, right?
Was that?
Contrail hasn't been developing the product for very long. So there's a lot of stuff in this that isn't, you know, the interface probably needs some work.
So we were a startup even a month back, right?
Yeah, that's right.
So I'm not saying that. Well, I'm not saying the interfaces work. I was saying, oh wait, you're pulling me actually. You know, I'm pulling up state, graphs and state of my network element, of my logical, physical, and virtual network elements.
Right.
Of my network topology is used inside OpenStack. Well, that's kind of useful. And if you actually look in the admin pages inside of Horizon, it's all about gathering the state, the utilization. Those are kind of neat things. And if all that visualization is already done, and you can just pull in a frame.
Right.
That's kind of.
So this may pull into a tangent, but we've talked to people doing OpenStack that aren't using Horizon.
So, you're absolutely right. Horizon's not the best thing, but it's what we have.
Well, I mean, I've seen deployments using, several other tools. Some of them commercial.
You can do whatever the hell you want. I don't care. It's just a thought.
So, we may provide it.
How far out of trunk do you want to go?
We may provide it in Horizon also, but we have to provide it in a non-Horizon include.
Whether we like it or not, Horizon is the dashboard. In the current state, right? It may not expose all the features as people are, especially on the search side, which is your target market. But absolutely, your target market is querying via the APIs. As just an operator myself, it'd be sometimes I just like to use stuff.
You know what? I would like to actually extend that too, because when I was looking at the Horizon UI, I think the greatest problem I had back there was the diagnostic. So basically something is broken, somebody has to tell me what is broken. It cannot be a call to the networking guy who works on it for half an hour to figure out which link is taking error, blah, 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 and is this flow going over this link, and that's why you have low throughput. So this is a visibility, a monitoring part, a nice GUI, but if you have diagnostic stuff, so hit a click and say that, hey, find out between these two VN, where are the flows going, and basically if there is any link which is taking the errors, which you can pull out from the physical infrastructure and correlate it, right?
Well, and now, I mean, absolutely, Horizon is a very simple rudimentary tool, self-service portal in a very simple way, right? But even log aggregation, being able to troubleshoot the state of OpenStack right now is a challenge, and anything that can be done to simplify that does help things out. But to your point, when you're running it, you're connecting via APIs, right? It's a developer tool set.
Right.
But as you're showing a freaking GUI, and your demo is centered around this, and they're like, oh, look at our other GUI, look at our other web GUI.
Right.
I think we would all like to see Horizon be more functional.
You want to go back?
Just the dashboard. I want to
That's
run
all
the nodes and see what it looks like after you've
It's
done
really
that.
difficult to.
Oh, it's a recording. Never mind. Sorry.
Yeah, it's
I thought you were doing it live. Smart man. Many OpenStack demos have died on the
Well, you know what they say, do a demo, lose a sale, right?
So what this one shows is basically how do you capture the packets from the virtual network. It sends a packet, it actually mirrors it to a packet capture, and you can define the mirror. And I think the font is really small, but just think of it as just you're picking up a VM and saying that any traffic coming from this VM, send it to the mirror, capture it, and send it out. And you can see the capture through a Wireshark or something, which has saved so many lives. So what the extra thing that we have done here is we have added a customized Juniper header on the top of the PCAP. And so Wireshark, when it's a Wireshark plugin through which you have to see it, so you can see that this is the Juniper packets coming in, and you can see the VN, and you don't have to correlate the IP address with the VN, and you don't have to do it. It basically gets automatically done. So that's the only, and this is where you see how so we generated a ping here, and it shows up as a PCAP capture.
Have you done, at least I know you guys are new to Juniper, but have you integrated those mirrored tunnels with the IDS or intrusion detection and protection tools?
I think those would all come under. That's a great point, and I think we should do that because I think that's a great part, because when we were trying to solve the same problem of Arbor, so in Microsoft we had this DDoS mitigation system where you route everything to the Arbor DMS and scrub it and send it back to the server, right?
Yeah.
The point was, how do you detect that server is coming under attack? So ideally you run some IDS, a host-based IDS in the server, and the moment you capture some signature, then take that flow, take those IP addresses, signal to BGP, and let Arbor signal those prefixes, and pull it into the Arbor, scrub it, and send it back, right? So those two connections is a great
Well, and
thing to do.
there's a lot of people on their Amazon clouds are putting logical caps in their instances and popping them to IDS, and then on their clouds that they're managing locally, having IDS and IDP, so they have a consistent view of their security stance.
Right.
And you know, as people are building these OpenStack clouds, they're trying to emulate the tools they're using at Amazon.
Right.
It's
I think,
anything to make
it's
that
a great idea because
pop out. One
but
thing
the-
right now, people are doing at the instance level,
Right.
they're doing like virtual tabs and stuff like that. And if you can apply that logical replication of that flow in the network level layer, it makes it so you can reuse other AMIs already published, or other
You're
concepts.
absolutely right. So
Yeah.
because the visibility you have here is upfront visibility, right?
Yeah.
In the fact,
Well,
this is such
it's
an
transparent,
important data set.
and if your host gets compromised, they ain't seeing a freaking ton interface on it,
Right.
right?
Right.
But your vSwitch there is Open vSwitch, wasn't it?
Which one? The switch?
The vSwitch
Uh-huh.
on that demo was that Open vSwitch.
No. This is all our V router and the.
Contrail V router.
This is our.
Oh, that's with the agent on there. Okay.
Yeah. So there is no open VS here. So I'm coming to the. I think the demo is over. I think I can open it up for whiteboarding and question and answer. So I have a few more minutes. Or you know what? You can always reach out to me. I'm here now, part of Juniper, and I can. Any of you interested in a real demo? You want to play around with it? Because when I got into it, I myself wanted to configure a MX. I wanted to see if it really works. And then I actually got myself a couple of MX10, and I had to go way back in my configuration background. I did all this thing in 2004, and I did actually put it together, and it worked. Actually, I could ping up VN, and so I think, okay, it works.
Well, and so you in one of your earlier slides, you talked about service chaining.
Yeah.
And you talked about this. We actually, Josh, you had a discussion, a really bright discussion while I was really drunk last night, about figuring out the topology of your network and communicating that in the overlay network on top of it. So your physical topology on top of there, and you might have instances in different areas in your virtual network, and maybe they're out in the physical network. And to be able to figure out what the best path is for that chaining.
Right.
Can you kind of maybe whiteboard or communicate a little more about how you accomplish that?
Yeah, so in general, I myself have a philosophy on the physical network, right?
Yeah.
And this is my own philosophy. I'm not taking any positioning yet. So to my mind, the physical network, so in general, when you actually build a cloud service, you have to optimize for the most expensive resource. This is how people actually make money out of it, right? If it is CPU, make sure that if the CPU, in order for the CPU to do 100%, whatever bandwidth it needs, it gets that bandwidth, right? You cannot actually, so the idea is how can you make network, how can you overbuild the network in a way where it never comes in the way of making the CPU go 100%, because that's the most expensive resource.
Yeah.
So in general, I particularly, and this is, if you look at the VL2 paper that we authored in SIGCOMM in 2009, where all this overlay kind of got in, I wanted to, and this is what the Bing looks like, this is what everything looks like. So you have the clause network, which you purposefully overbuild it, because you don't know how the application is going to evolve in the next 5 years.
Yeah.
Because invariably it is going to be more hungry about the traffic. And what happens is network infrastructure is like building highways. Once it is built, adding another lane and doing those capacity management, those are so old times. And that happened because the ports were expensive and you didn't want to do the capital overlay upfront. So you say that, okay, I'm going to pay whenever it needs, and there's whole capacity management and stuff, all those things were there. So my personal philosophy is build a clause and overbuild it. In general, build it with 40 gig if you possible in the spine layer, but you don't have too many.
Well, yeah, I
devices.
mean, you make an assumption that you have a net new spine link network you can establish. So what if you're coming into, I mean, what if you're retrofitting, you know, there's a lot of core aggregation access networks out there that you're having to retrofit or bring a new service into it. And you I inferred some level of intelligence in that service chaining, right?
Right.
I was just making an assumption of I got any bandwidth anywhere.
No. So let me actually take that. So basically, you're absolutely right. So in a new kind of build, I would like to overbuild it in a consistent way so that you don't complicate it.
I'd love unlimited budget, unlimited bandwidth, and
You're
limited
right.
time
You're
myself
right.
too.
Give it to you. So now, if you have a standard tree kind of stuff, and you have congestion here, congestion there, and that kind of stuff, I think we are positioned in a way inside Juniper where we can suck out all the information from the, you can get it through regular SNMP, and you can get the in-octet, out-octet from any link, and you can find out where is the condition, and you can feed it back into the control node, and you can make it actually choose a different service endpoint depending on either the network congestion or the service congestion itself. Because sometimes you have a F5 load balancer, which you know the number of connections per second, the new connections per second is going to blow up over 800,000 new connections per second, right? And if you're seeing that it is already hitting 500,000 or 600,000, don't send any more connection to that guy. Send it to somewhere else, right? You can always do those things. So at the end of it, it's basically access to information.
Are you doing that, or are you using
No, right now we are.
RSVP, or you?
Right now we're not doing it. So basically, you know.
Let me put it in a different way. Whether it's a horizontal scalable model or you're going to a legacy model, the problem of controlling the network provision of network topology is probably not the highest order problem. First of all, you need to control the actual provisioning of the appliance traffic.
I'm not arguing about what's the problem. I was just trying to learn about your product.
So I think the way I look at it is right now we are not doing it, but the thing is, do you have the infrastructure to use the intelligence if you are fed with the intelligence and information? So the control node is infrastructure, the SDN control node is infrastructure where you can get the intelligence. It's just information, right? You have information on if a service node is getting utilized or a link is getting utilized. And once you get the information, you have to just work on the information to take an action. So I think we do have the control node, and you have that infrastructure where you can take the information. The information is available. With Juniper, we being part of Juniper, I think we are going to get more information. But the thing is, it's IP network, right? So basically, think about SNMP for that matter, and whatever granularity you're getting the data, and it has its own nuances. Now, and the service, how hot the service is, and then F5 or any other firewall also advertises everything to SNMP. And you can capture data from there, and you have to think it through and make sure that you don't get into oscillation. For example, you take everything from there and send it to another service pool, and now that is full, and now you're bringing it back. So there has to be some dampening that has to get built in, and there has to be slow bleed out, slow bleed in, that kind of stuff. But it's doable, right? So we have been a startup, we were just prioritizing all our
It's not a negative knock. I mean,
Right,
you guys
right,
are doing
right.
an interesting thing. And please don't misunderstand a question as
No, I think
as
it's
an attack. I mean, it's dangerous
not an attack.
nowadays, but
It's not an attack.
no, it's just interesting to go through your thought process and to see what problems you're trying to solve and how
It
you're
is
solving.
actually a great question, because this goes into how do you efficiently utilize any resource?
Well,
That's the
and
key
even
of the
more so,
question.
in service chaining is rather in the service chaining question is especially as we're not instantiating services in a defined services layer anymore. They may appear anywhere in an access layer, right? And you might end up with, and you talk about how do we over time, how do we avoid kind of echoes throughout our infrastructure, and and this triggering that and triggering that, or failure situations, and it's interesting. You may end up with all of your because of how your instances were instantiated,
Right.
you might end up with all of your security controls within one access layer switch in your data center. It's possible, right?
That's a very good question.
And at the network layer, how do you manage around that?
So this is a fantastic one, because what happens is in large scale application development, they always have a concept of affinity. So they always have affinity.
Yeah.
So which server, and you have to actually bring these two components in two different parts of data center just from reliability point of view. You want to put them in two different 3-9 zone, and I think this thing is important.
In developers now, as they're developing these new class of applications, they're very aware of availability zones and regions and affinity. Network engineers, not so much, right? And a lot of times, you're calling an API, and these design patterns for network elements aren't as well defined as they are for applications right now. And the ability for a network product, at least sanity check across it.
I think we should definitely take that apart, because this is the next frontier of good intelligent
Yeah.
It is the
orchestration
next
that we
frontier.
can do.
You hit something on the head. It's network as a resource, and you start adding network into the resource pool with compute and memory and what other finite resources there are.
Right.
And it's not always about steering the network bandwidth. I mean, you go back to Affinity. At some point, you have to have a higher order network intelligence layer that goes, okay, what is that affinity? Because maybe we didn't know, or maybe we didn't get designed for it, because it is the old architecture. We're trying to build a new architecture. So at that point, you have to decide: are you steering the bandwidth, or are you steering the host into an affinity zone?
Right.
And that is where this goes. The thing that concerns me about what you said is you keep mentioning SNMP. That is not
I
the
know.
metric.
See, the thing is, let me give you
That is not where you collect the data to figure out this affinity.
I know. The thing is, like, we had this problem, right? We wanted to have a vendor neutral situation where you pretty much work with any physical switch and stuff. And once you actually, but SNMP is almost the lowest common denominator, like you have everywhere.
Sadly,
But
that's
That's
accurate.
the sad. That's why I was saying that. But ideally, you should suck as much data possible out of that box and make it, feed it to your intelligence system, have big data or some kind of infrastructure to churn it real time every time, and then orchestrate it in a way which makes most sense and which actually, because the cloud services, they're working on a very low margin. And if you have all this fluffs on the top of it, somebody else is going to eat your cake. So you have to basically compress it and make it so thin so that your resources are being utilized.
So eventually that means analyzing and deconstructing flows in order to get that information. SNMP is not the way to do it.
Yeah.
So I'm
I
not,
cannot
we're
agree
not
with-
arguing. It's
I
just
cannot agree more
I
with
kept
you.
hearing SNMP
I know.
for that. and it's
I
not
cannot
this.
agree more with you because SNMP, so in our infrastructure, we couldn't even read multiple times from SNMP. For those
You know
guys.
what I would do at
And
that
the
point?
whole thing, huh?
I would put Keta in query all my instance locations and and do an SPF run for all my network elements that are running as an instance.
Right.
And run the inverse of an SPF run actually.
Right. And
Actually, yeah. You would do it that way. Query it via an API. Now, I'm not the best at anything, but it's one idea.
right.
You know.
Right. So
Good
SNMP,
stuff.
not my position. Not my position. I don't like it. Let me tell you.
SNMP
Alright,
is a
so
read-only.
It's old. It's way old. It has overlived its life.
Using
So
Keta.
all right. So that was it. So I'm always reachable. Reach out to me.
Thank you very much.
Thank you.